Welcome, students, to STEM Thinkfinity. Today, you will learn chemical reactions and equations. So today, we will understand what exactly is a chemical reaction. How can we identify that a chemical reaction has occurred? Whenever a chemical change occurs, a chemical reaction has taken place. Chemical reaction means the original substances disappear. New substances are formed, and the change is usually irreversible. For example, paper burning equals chemical change. Why? Because after burning paper, you cannot get paper back. Chemical reactions are the processes in which new substances with new properties are formed. In a chemical reaction, reactants are transformed into products. The products thus formed have properties which are entirely different from those of the reactants. Look around carefully. A large number of chemical reactions keep on occurring in our daily life. Milk turning into curd, ripening of fruits like mango, rusting of iron objects left in open air, tarnishing of silver objects, respiration in our body to get energy, process of photosynthesis, burning of fuels like petrol, diesel, burning of fireworks are all chemical changes which involve chemical reactions. In all these cases, the nature and identity of the initial substance changes because of the chemical reaction which takes place in it. Now let us come to the example of a chemical reaction, burning of magnesium. Please note that magnesium is a silvery white metal. Magnesium metal is available in a science laboratory in the form of a magnesium ribbon. It looks silvery and shiny. It is a metal, chemically written as Mg. Now we burn it in air. When a magnesium ribbon is heated, it burns in air with a dazzling white flame to form a white powder called magnesium oxide. Actually, on heating, magnesium combines with oxygen present in air to form magnesium oxide. The burning of magnesium in air to form magnesium oxide is an example of a chemical reaction. In this chemical reaction, there are two reactants, magnesium and oxygen, but only one product, magnesium oxide. The properties of the product magnesium oxide are entirely different from those of the reactants, magnesium and oxygen. Why is this a chemical reaction? Because a new substance, MgO, is formed, it has different color, it has different chemical properties, energy is released in the form of heat and light. An important question now arises: how do we come to know that a chemical reaction has taken place? This will become clear from the following discussion on the characteristics of chemical reactions. Now look at the right side of the slide. These are called indicators of a chemical reaction: change in state, change in color, evolution of a gas, change in temperature. Let us understand them one by one. The conversion of reactants into products in a chemical reaction is often accompanied by some features which can be easily observed. The easily observable features or changes which take place as a result of chemical reactions are known as characteristics of chemical reactions. Evolution of a gas. Take some zinc granules in a test tube. Add dilute sulfuric acid over zinc granules. We will see the bubbles of hydrogen gas being formed around zinc granules. So the chemical reaction between zinc and dilute sulfuric acid is characterized by the evolution of hydrogen gas. Change in color. Some chemical reactions are characterized by a change in color. Take some dilute potassium permanganate solution in a beaker. It has purple color. Add lemon juice to it dropwise with the help of a dropper. The purple color of potassium permanganate solution goes on fading, and ultimately it becomes colorless. So the chemical reaction between citric acid and purple-colored potassium permanganate solution is characterized by a change in color from purple to colorless. Change in temperature. Some chemical reactions are characterized by a change in temperature. Take a little of quicklime in a hard glass beaker. Add water to it slowly. Touch the beaker carefully. The beaker feels to be quite hot. Its temperature is high. So, we can say that the chemical reaction between quicklime and water to form slaked lime is characterized by a change in temperature, which is rise in temperature. The reaction between quicklime and water to form slaked lime is an exothermic reaction, which means heat-producing reaction. We will now give one example of a chemical reaction in which heat energy is absorbed, due to which the temperature falls. When barium hydroxide is added to ammonium chloride, taken in a beaker, and mixed with a glass rod, then barium chloride, ammonia, and water are formed. A lot of heat energy is absorbed during this reaction, due to which the temperature of reaction mixture falls and the bottom of the test tube becomes very cold. Thus, the chemical reaction between barium hydroxide and ammonium chloride to form barium chloride, ammonia, and water is characterized by a change in temperature, which is fall in temperature. It is an endothermic reaction, which means heat-absorbing reaction. Change in state. Some chemical reactions are characterized by a change in state. For example, when wax is burned in the form of a wax candle, then water and carbon dioxide are formed. This means that during the combustion reaction of wax, the physical state changes from solid to liquid and gas. Thus, the combustion reaction of wax candle is characterized by a change in state from solid to liquid and gas. There are some chemical reactions which can show more than one characteristics. For example, the chemical reaction between zinc granules and dilute sulfuric acid shows two characteristics: evolution of a gas, hydrogen gas, and change in temperature, rise in temperature. Similarly, the chemical reaction between potassium iodide solution and lead nitrate solution shows two characteristics: formation of a precipitate, lead iodide precipitate, and change in color, from colorless to yellow. But what actually happens during a chemical reaction? You have studied many reactions: rusting, burning, respiration. Let's go deeper. Look at this slide carefully. On the left side of the slide, you see two types of particles, AA and BB. These are our reactants. Now see carefully. Each green ball marked A represents one type of atom. Each black ball marked B represents another type of atom. So before reaction, substances have definite atomic arrangement, definite bonding, definite properties. Properties depend on arrangement. Now look at the center part of the slide. You see atoms colliding and rearranging. This is the most important concept. Many students think, "Sir, do atoms get destroyed?" Atoms are neither created nor destroyed in a chemical reaction. They only rearrange. Why does rearrangement happen? Because atoms want to achieve lower energy, more stability. When new bonds form, energy may be released or absorbed. That is why some reactions produce heat, some absorb heat. Example: burning releases energy. Photosynthesis absorbs energy. But in both cases, atoms are simply rearranging. Now look at the right side of the slide. Earlier, we had AA and BB. Now we have AB and AB, new substances. Now think carefully. Are the atoms new? Are the atoms different elements? But properties are completely different. This is the most powerful idea in chemistry. Same atoms plus different arrangement equals completely different properties. Now look at the conclusion. It says the fundamental change in a chemical reaction is the rearrangement of atoms to form new substances, not a change in the atoms themselves. Comment below. Why does water have different properties from hydrogen and oxygen even though it is made from them? Whenever you see a change in daily life, ask yourself, is a new substance formed? Are properties changing permanently? If yes, you are witnessing chemistry in action. In the next video, we will learn how to write chemical equations properly, how to balance them. If you found this explanation helpful, like, share, and subscribe to STEM Thinkfinity for concept-based science and STEM learning. Share with your classmates.